All right. Good morning, everyone. And before we start, I am going to play a nice song for us.
Hey, I just met someone new, but to keep in contact, what should I do? Oh, 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 oh. Do I ask them for their email, username, password, Instagram handle, game, or code? Friend them on Facebook, ask for their number, or even follow them home? I don't know. What if the answer was simple and sweet? Ask him one question, wouldn't that be neat? I'd say, hey, what's your at sign? What's your at sign? What's your at sign? They'd say, hey, here's my at sign, here's my at sign, here's my at sign.
All right. Man, did I miss a demo day? Oh my goodness. I am so happy to be back sitting here and saying good morning. Happy demo day again. And for all of you joining, thank you for joining. Happy Friday. And you may notice that I'm not actually on stage by myself today. I am sitting next to, of course, Mr. Don Witt. It is my great pleasure to introduce him today.
Glad to be here.
Yes, he will be joining me in moderation for a couple of the panels that we'll be having. Don here has a long and distinguished career in telecommunications and mobile technology. That's like a perfect fit for the At Company. He's currently an active blogger, also a writer and commentator at the Channel Daily News. And he is also part owner of HOD Pros and a telecommunications channel advisor. And as long as being an advisor for them, he's also an advisor for us. So, Don, take it away.
Thank you. Really, that was a pretty nice intro. I really appreciate it. We have several panelists that are going to be with us today. And we have Jimmy Jones, head of security at Zariot. And with the At Company, we're going to have Colin Constable, the CTO and co-founder, as well as Kevin Nichols, the CPO and co-founder. And wanted to thank you for that intro. And as we get started here, I'd like to have each one of you introduce yourself just a little bit and briefly, and we'll talk about the companies as we go further down the with the panel. So, Jimmy, why don't we start with you, and can you give us a little background on Zariot?
Sure. So my name is Jimmy Jones. As Don says, I'm the head of security at Zariot, and Zariot are a global IoT connectivity provider who are founded with a real focus on security. So what that meant at first is we were looking at our own network security. There are some well-documented problems with mobile security. It's still the most secure way to connect to IoT, but there are some issues. We do have some. And we were very lucky when we were formed as an IoT company that we had a sister company that actually provides all of the security for multinational mobile operators. So as a small MVNO, we were able to adopt that at a very low cost, free, because the same guy owns us. And that means we're able to bring a different agility to your business. So when your IoT needs to be secure, you don't have to go to the multinationals who may be quite slow at reacting. You can come to us, and we're much more agile as agile as your business. And that won us awards with MWC and some other events. When I joined about 3 months ago, I thought that's not quite enough. So I took Zariot a little bit further. I wanted to expand it because I see IoT as an ecosystem. It can't just be a connectivity provider. You have to be part of an ecosystem, because nobody's going to be able to know everything in the way that IoT is going to develop. So we have to cooperate with each other. So the first thing I thought of doing was looking at the data path. We'd done the signaling. I'd like to look at the data path, and I was lucky to find there was a guy actually in our business who's very, very skilled at working in SIMs, which is unusual because I've worked in much larger telcos and we've never had that ability. Then I thought, well, there's a lot I can do with this. I can start to secure the data path, and I ended up talking to you, Don, on I can't remember what it was an interview for, but I had an interview with you, and you introduced the app company.
Yeah, I wanted to find out a little bit about your new company, because I know you did a really good job with your old one, and wanted to see what your plans were. And as it turns out, exactly, we got to talking, and being a protocol guy myself, like I was understanding what you were doing, and it seemed like there might be a good fit.
Yeah, well, you're the father of the partnership. I'd put it like that. So yeah, you saw the opportunity, and that was great. And when I was introduced, I saw a little bit of the opportunity. It's actually worked out a lot better than I first thought. But what's definitely there, and I think what we're very, very happy with at Zaria is we've been able to bring a level of innovation in such a short period of time. That we think we can deliver end-to-end security on the data path with a much lower barrier of adoption than previously available in the telco industry. So that's all down to the app company and a little bit of luck on my side. So that's roughly where we are. I could go on, but I'll let you.
No, that's fine. You did a great intro there. Thank you. Kevin, maybe you could give your a little background on yourself as well.
Yeah, sure, Don. Hi, everyone. I'm Kevin. And Colin, Barbara, and I started this company a couple years ago now. And prior to that, I spent many years doing a bunch of startups, from little companies like Sun Microsystems through NCD, through Netmosphere, to Biopop, to a bunch of them. And served various roles there, sometimes CEO, sometimes engineering. And then yeah, it's one of the odd paths in my career. I ended up over in London for a number of years, working for British Telecom. I was doing mergers and acquisitions for them. And I was fortunate enough to meet this guy, Colin Constable. And we did a hackathon back in 2007. And this long enough ago, we actually called them hot houses, not hackathons. But anyway, so Colin and I became fast friends, and have been doing all kinds of crazy stuff ever since, including starting this company. So Colin, over to you, or back to you, Don.
Yeah, Colin. Yeah, no, great lead. If you could give us a little background on yourself, that'd be perfect.
You're on mute, buddy.
I need to be off of mute, first of all. So yeah, my career started a long time ago, a very long time ago, in telecommunications. So I have networking in my blood. I started British Telecom. I was there for a decade, and then decided to jump ship to a different industry, banking. So I worked at Wall Street, and that's where I met Kevin when I was at Credit Suisse. I was also looking after networking and security there. And one of the main reasons to go to a bank is you've got all the big toys at the bank. What you did then. So that was a blast, and then moved to Silicon Valley with Juniper Networks, and then the universe couldn't keep Kevin and I away. We worked together opening up a innovation lab for Deutsche Bank in Silicon Valley, and that's when I got bitten by the startup bug pretty badly, and I've been working on the edge of either startups and enterprise, or enterprise and startups ever since. And like any good startup, they always start over a cup of coffee. And about 7 years ago, maybe more than 7 years ago, Kevin and I were having that cup of coffee, and we decided to do something about it. It didn't quite work out then. The technology wasn't quite ready for us. But 2 and a bit years ago now, all the stars aligned, and it's just been a rocket ship ever since, Tom.
Great. Thank you very much. Like both of you and Jimmy to a certain degree, I've had a lot of communications in my background, but what I find is that we're in one of the most exciting times in communications ever. It used to be literally 150 years of nothing, and now we've got VoIP, SIP, SDN, NFV. we've got CBRS, we've got 5G, and of course we have IoT, which is the one we're going to be talking about now. And when I started following this about 2014, I guess it had transitioned from machine to machine into IoT, but it seemed to me like it was really a wild, wild west. I mean, everybody was bringing out switches and connectors, sockets, sensors, pretty much everything. And it was clear to me that this is going to be an unlimited environment. And really the goal for IoT, from what I could see, was to make things more productive, to make products safer, to make end products more precise and effective. It was really helping homes safer, cities to be more environmentally green, and it applied to vertical markets, horizontal markets, pretty much every aspect of life and the world around us. So it really had no limits, and I wanted to stay in touch with this one. Unfortunately, as all of these products were coming out, security seemed to be not as important in the development process as one would like. And the other side of it is that there were really no standards either, so there was nothing to follow. As a result, right now, we're sort of stuck in a situation where consumers really need to be on their guard and when they're looking for IoT technology to deploy, they've really got to be paying attention. So this is where Zariat comes in, and Jimmy rides in on his white horse with the Zariat technology, and they actually have some really very interesting technology, and Jimmy's explained a little bit about that, and they're starting to tame the wild west of IoT world. So Jimmy, maybe you can get into a little bit more of the product definition that you have for Zariat over there, with maybe with the SIMs and how that works.
Yeah, I mean,
better the IoT world.
Sure. Well, I've touched on already what Zariat do on our USPs, and you're exactly right when it comes to IoT. And we're just at the very, very tip of the iceberg. At the moment, IoT is still very much M2M, very much machine to machine. It's siloed environments where you have devices talking to large data storage systems, and that's around about it. And that's already proving quite difficult to secure. But that's nothing. It's going to move on. There's going to be a point when all that data needs to be collected, and to actually make something worthwhile out of IoT, you need to do something with it. You need to do something productive. You need to not just take the water measurements. You need to notice that there's too much water going in that house. There's obviously a leak. Let's cut it off. So it becomes proactive, and that's going to get more and more. And you can equate that to IoT being a baby. At the moment, it's difficult to look after, but it sort of just sits there in the basket. It's about to turn into a toddler, because it's going to start making its own decisions. It's going to start running around the house and sticking its fingers into the electricity sockets. So that's where we're about to go to. So it's hugely important that we look to start to securing this stuff, because it's going to affect everything around us. We're already seeing Gartner saying that they can see IoT and other physical cyber threats becoming life-threatening in the next 4 or 5 years. That's a scary thought, but it's already there. That they can see it being weaponized, and that's going to cost billions of dollars if you're attacked just in litigation, and that's not even thinking about if you actually hurt somebody. So there's a lot there that's actually happening, and we need to look to secure that. It's imperative, because the thing with IoT is it's now starting to absorb into our lives, and that's really important, because as we start to have more and more IoT, as we start to interact with more and more smart devices, what happens is our physical identity and our cyber identity or online identity, they start to come together. That means all of these threats are no longer cyber threats, they're safety threats. So that's where we're at. And what we're doing at the moment is the first steps to that. And I think it's really, what happened was when I came to the At company, I knew that there was a initiative by the GSMA, which is the Global Mobile Operators Association. There was an initiative there called IoT Safe, where they look to encrypt via the SIM, and it's a fantastic initiative, and it definitely has its place. But it does have some barriers to adoption, because it does have a lot of certification. It has a lot of things a lot of hoops to jump through, essentially. So what I wanted to do was bring that to the masses. It should be everything, because IoT devices, when they all start to club together, they are going to be more and more powerful. It doesn't matter if the information from that meter, it doesn't matter to anybody. If you start to put it in a massive data pool and then start to apply ML and start to apply AI, you could have enough information there to hit GDPR or CPA, the California one. So there's a lot going on. But
Jimmy, I was thinking maybe this is where we should bring in the At company, and I think that you're right on the money with current solutions providing the security and everything. But ultimately, the At company has some technology that really could enhance your solution. And maybe Kevin or Colin, would you like to join in and give us your perspective on where Jimmy's at and how you might be able to enhance what he has?
Yeah, I think the well, first of all, I mean, this Colin, I've been hoping that somebody would do what Zariat's doing, and that there was a Jimmy out there somewhere. And so thanks to Don, we were able to connect up. So this is definitely an ecosystem play. I think with especially with things like with IoT and 5G, the number of devices that are directly connected to the internet is going to explode, and that just creates all kinds of potential vulnerabilities out there that I'm not an expert in, but Colin is. But I mean, if we're talking about circa 5 billion smartphones or connected phones over time, there's 10 times that many devices out there that at least that are going to be connected, and that should be mildly terrifying to people unless we can solve it fundamentally. And there we have a. I'm gonna stop talking about Colin talk, but we have our fundamental challenge in that context. Zariat solves, so we are super excited about that, and Colin can say why, because he knows better than me.
So the why is all about cryptographic keys, and where do you keep cryptographic keys, and how do you keep them safe? And on a mobile phone, there's most modern phones have a place where you can keep keys that's safe, and the person can operate applications that put keys into that place that's safe, and that's what we use for all the consumer apps we've got at the moment. But in IoT, who's going to be putting the keys in the right place, and how can you create that bond between the cryptographic keys that the app company uses and the piece of hardware? That's actually a fundamentally difficult problem. We had solved it by putting in TPMs, but that's expensive, and it's a little tricky, to be honest. And as Kevin said, our dream was, and I remember having this conversation 2 years ago with a security specialist, and they said, and we agreed, the best place for this is a SIM card. And we thought, yeah, that would be just awesome. But yeah, we know nobody could do that, like zero people. So when we met Zariat, and he goes, Jimmy said, yeah, what we'd like to do is put the security keys on a SIM card. That was my face. So behind the scenes, we were like so excited. And then when we met the Zariat team, we know how geeky you've got to be to be able to do all this stuff. And they got the right stuff. So yeah, match made in heaven for us. And I think it's awesome for in particular Zariat's customer base, because they can weld together a digital identity with a physical piece of hardware. And at the moment, we think about SIMs as sort of small bits of plastic, but that stuff is actually going to get baked into hardware. So it's it's a really nice, and as Jimmy said, far easier than having to go through the loops and hoops of going the GSM way. So I think this opens up many more possibilities.
So that really closes a big hole that's out there in the security equation. And since the IoT device will be located at the edge, I mean, this is perfect. It seems like it's going to really close the loop on that.
Yeah.
So, Jimmy, let us know how you're going to be integrating this thing now. Tell us a little bit more about that process.
Well, as Colin described, what we're creating is a root of trust on the SIM. So that's the root of trust is the foundation of any sort of trusted computing base and security policy. So what exactly as Colin described, we take the security keys and we put those functions onto the SIM, which is the right place to put it, because the root of trust needs to be inherently, well, trusted, for want of a word. So particularly in IoT devices where they can be located anywhere, it has to be tamper-proof. And as you said, we're moving away from plastic, which could be taken out, to eSIMs, which is essentially a SIM on a dedicated chip, which is really, I think, just a stepping stone until we get to iSIM, which is a SIM on it's part of a system on a chip, and it's just an inaccessible area of that. And if you start to put that with some other tamper deterrents, physical ones, for instance, some chips use UV light, sensitive coatings to destroy the chip if you try and cut it. That'll deter almost any hacker, except if you start to get to nation states and things like that. You have to do some best practices as well. Obviously, you want to make sure that the pre-shared keys are personalized, then they're not guessable and stuff like that, and randomized. But if you do that, then you have the opportunity to actually address 4 of the 5 main concerns of IoT. So the main concerns for IoT are availability, privacy, security, identity, and longevity. So availability, that's all that signaling stuff I was talking about. But the rest of them, it really comes down to this: the privacy and the security. If you're encrypting everything, we can't read it. The app company can't read it. So that's pretty obvious. On the identity side, being able to do that end-to-end identity to avoid spoof devices or old devices being reused and things like that, or even authenticating between device to device or network to network and peer to peer, which will be more and more important as we move to 5G. That's hugely important. And the longevity is given to us by the actual cellular networks themselves. You've got legislation coming out everywhere where 5G is particularly being looked at. There's an executive order coming out at the moment in the US. The EU are ratifying something on wearables and IoTs in Q4. So that legislation's there, and plus the governments are invested. It's the one area of the spectrum that's licensed. They can look after it. And if you think that the US sold they sold a small part of their 5G license for $81 billion. How much are they going to sell 6G for? So you've got longevity built in. But the most important thing is it simplifies and secures the deployment of an IoT solution, because it's always there. So particularly with release 17 of 5G coming out, which is all the stuff on massive machine to machine type communication, I think it's the ideal time and the ideal partnership to be able to secure it.
Thank you, Jimmy. Colin or Kevin, can you provide, I think one of the things that's really interesting about what Jimmy's doing is getting that security locked into the device. But there's another aspect of that can be really applied. And I think that comes in with the personas that we've really been talking about from the beginning with the app technology. And how can the persona be applied to a device as far as it relates to the data? Maybe you can give our listeners a little bit of insight on that.
So when we designed the protocol, we were very keen on making sure that the protocol was really set for people. And one of the interesting things about people is when you ask a person the question, you might not get the same answer. And one of the sort of leading things that gives you a different answer is who's asking the question. So we really wanted to bake that into the protocol. So the way we do that is we have cryptographic proof that you actually know who you're speaking to. So that's sort of number one. You actually do know, cryptographically proven, that you're actually speaking to another @sign, and you know it really is that other @sign, which gives rise to giving different answers to different @signs. So if @Kevin asks me something like, I know, what's your location? I'll just say I'm at home, and he has all the context of where my home is and all the rest of it. But if I know @UPS asks me what's your location, I might give them the full postal address. So that's how a person interacts, and that's how the app protocol interacts. Now, if you imagine an IoT device, maybe publicly the IoT device is quite happy to give away certain metrics within a with certain level of accuracy. This package is in California. If you're tracking an IoT device, that's going through the mail, for example. But if the actual sender of the IoT device in the mail asks, "Where are you?" they might get a completely different answer down to the exact grid location. So that it gives rise to, I think, possibilities that many IoT developers have not had access to in the past. I mean, generally, when you're talking about IoT devices, you get telemetrics, but they never really ask, who's asking. And adding that into the mix, I can't imagine the number of different ways you can apply that. So if you group a number of different answers together, we call that a persona. This number of people or this number of @signs get this answer. That's one persona. This group of IoT @signs, when they ask a particular question, get a different answer. We just group those together. Pretty easy to do, and we just call it persona because that's what it's like in people land, right? So are you asking me as a dad? Are you asking me as an employee? Are you asking me as a friend? They're all different personas. But I'm the same person, but I got different personas. And bringing that into the IT world is going to be a lot of fun. It's a lot of fun.
Kevin, you have thoughts on how this will affect the IoT environment as well as the consumers that Zariat will be serving?
Yeah, absolutely. It's always interesting, and you kind of have to always remind yourself, excuse me, that as Colin just described, both sides of the interaction know who the other one is. So you could have something like, I don't know, if you said, configuration at powercompany.com or configuration at some power company, and every device could look up I'm going to look up, configuration at power company. Because of that kind of polymorphism, every device would get a different answer, but with a single lookup. And so everything works both ways. I mean, I think it's really interesting when you consider security in the context of, especially with IoT, is that both sides of the interaction are known to each other, and the response can be addressed to that, and it doesn't always have to be the same response. And so that's fascinating. And I think it's going to be just that feature is a game changer for how this kind of stuff will work in real life. Because right now it's sort of like I'm going to trust some other, intermediate to be the provider of security in the context of a device, and everything is one size fits all. And I'm secure from what the device sends to me, but what about the other way? What about the other direction? That's really interesting, I think.
The other thing we thought about, Don, because I'm an old network guy and the internet hasn't changed very much, we still have problems with network address translation and firewalls and all manner of middle boxes. The underlying app protocol is from the client all outgoing traffic. So that means that you can have a firewall that has deny, deny, deny from any external. So you can have a sensor, an IoT device with a firewall in front of it that says deny everything. The IoT device itself only needs to make outgoing calls. So it's it's like a diode, if you like, that we've engineered in such a way that the actual client only has to make outgoing calls. Now that may seem like a small thing, but believe me, for a network engineer, that makes life so much easier. So, we've been bitten by other protocols that were not so friendly to network address translation of files. The last thing you want to do is go to your network administrator and say, yeah, can you open these firewalls? The answer is always no, and you can very rarely get a yes. So yeah, the client actually makes an outgoing connection to a individual port, but it's an outgoing connection, not an incoming connection. And that's for notifications as well as normal interactions. So even notifications are reversed by the way the protocol works.
I remember some of our conversations. You were actually saying that some equipment could be eliminated based on the implementation of the at-company protocol, and that would basically be reducing the cost of the installation as opposed to making it more expensive.
Yeah. So one of the, I mean, yeah, as I said, I've been in the network world for a long time, not as long as you, Don, but lots of people have been selling lots of boxes to do a half decent job. And sort of probably the classic one is SSL, so or VPNs. They're sort of interacted over the years. But if you buy a VPN box, you're just encrypting network traffic, and then the other side of it, it's actually open. What you get with the app protocol is from the source of data to the sink of data, wherever you're sending it, it's end-to-end encrypted. So there's literally no need for VPNs anymore, because each one of the app signs has its own unique VPN between itself and any endpoint you want to communicate with.
Moving on to a little bit different subject, Jimmy, how did the recent Berkeley Hackathon go? What's the results of that? I think you had some awards that you gave out.
Yeah, it was fantastic. It was the first time we'd showcased our partnership with the app sign. It was very successful last weekend. We had a number of we had a lot of interaction, which was cool, and I think it's something that we want to look at to do more of in the future. We want to see innovation come through, because we think that IoT in particular should be driven by the application, by the actual goal, rather than by the technologies. I think we need to start turning that on its head, and particularly as a telco team, we need to start taking other people's points of view, rather than just keep pushing our technologies onto the consumers and the manufacturers. We need to start listening to them, because we can see that. I mean, if you go all the way back to sort of WhatsApp and things like that taking over SMS, it's because the telcos were too inward looking. This is a completely different scale to that, and I think dealing with students in particular who have that fresh ideas and fresh points of view was fantastic. We had 3 winners. We've spoken to them all, and we're going to feature them. We were impressed enough that we're going to feature all 3 of them on our website in the next couple of weeks. We're going to have a little innovation panel, and they're going to be the first. There's 8 of them. The first 8 stars of our innovation panel. So, fantastic result for us.
Thank you, Jimmy. It sounds like it was a lot of fun as well.
Yeah.
So Jimmy, Colin, Kevin, let's see, we have a couple of questions here. Maybe I'll start with Jimmy. You mentioned Zarya signaling network security. Why would you need that? I know from the old days, there's SS7. Actually, it's not the old days, it's still being used, but SS7 was really the rule book for all communications. But now you have SIP, you've got VoIP, you've got diameter, GPRS, tunneling protocol. and all of that stuff. Maybe you could explain a little bit about where we're at with it.
Yeah, so you're right. SS7 has been around for probably 40 years. I was told in the year 2000 that as an engineer, I needed to move away from SS7 because it would be dead in a year, and SIPWInd H323 would take over. So then 20 years later, I had to relearn it because it's still there and it's still being used. It's not used in the voice setup, but it is using all those mobile operations outside that. So all the times you roam to different operators abroad, all of that communication is on SS7 mainly, a little bit of diameter. They're old protocols and they're not designed for that. They're designed for being on point-to-point twisted pair wires. Me and you, Don, we're old enough to remember that. And in the year 2000, essentially what they did was that was too expensive, so they put it on IP, but they never did anything above it. So none of that. It's not designed to be secure, and it's not secure. And MNOs are addressing it, but not at the pace you would want. Some of the really big players, your AT&T, your Verizons, etc., they've spent millions on it, but it's too big an investment than some of the others. So what that means is anybody who can access that network, and that network is every operator in the world. So whenever you want to go abroad, you expect your phone to work. You expect to be able to ring your wife, I've got here. That means that AT&T have to interconnect with Fiji Telecom, with Hawaii Telecom, or wherever it is, Mozambique. So if you can compromise anybody in that group, and there's about 1,000 operators globally now, you can send messages to the network, and they're not difficult. Once you've got access, it's not difficult to actually create a message where you can gather the IMSI, which is the identifier. So there's one message I need to send to go from the number on your card to the IMSI identifier. And when I have that, then I can do all sorts of things. I can tell the network that you've roamed onto me. If I tell the network that you've roamed onto me and there's no firewall, the standards say they have to respond. They have to give you, and they can't challenge. So that means I can now intercept all your SMS. I can even sit man in the middle. I can gather your calls and send them back to you and listen in. The SMS one is quite interesting, right? Because that one's the one that tends to hit the headlines. That's where bank accounts get broken, where you saw Reddit get hacked, because two-factor authentication is a lot of the time still done on SMS. You shouldn't do that, by the way. And I can intercept those. If I can intercept those, then I can access your bank accounts. On top of that, we see things like Circles last year, where they did location tracking across the global scales. Even this week, we've seen the stuff around about Light Basin, which is a hacker community, quite famous one actually, and they accessed telephone networks via the DNS, and they sat there for 5 years without being discovered until CrowdStrike found them. So there's a lot going on there. So you do need to protect. So you do need the firewalls. And like I said, we were right at the beginning. We were massively lucky that the guy who owns Zaria also owns another company, Cellusys. They sell all this stuff to the multinationals. So we basically took it and put it in our network. So we were massively lucky there. But it doesn't take much of a Google to find two-factor authentication fraud, or just look at the unhappy face Reddit put on when their VPN access was hacked because it used SMS. They weren't happy. A couple of years.
Kevin, Colin, do you have anything to add onto that? I know Jimmy pretty much covered everything. I think he left a little bit for you guys, didn't he?
Yeah, Jimmy's on the money. The attack vector is definitely the signaling now. I think we can solve the data path, and that's why the partnership between Zaria and the ad company is perfect for the data path. But the signaling path, that's what Jimmy's talking about here. That needs to be protected, and actually they need updated protocols themselves. So over time, I'm sure we'll get done. But at the moment, it's definitely a telco weakness, and that's why you need people like Jimmy and people like Zaria to make sure your signaling path is clean and nobody else is playing with it.
Kevin, anything to add?
No, just still really excited. I mean, this is like I said, we've been hoping, and we found Jimmy and Zaria much earlier than I thought it would happen, and it was just like, and seriously excited about it. This is actually really important. So we're thrilled.
Hey, one more question, and it has to do with the 5G. Everybody says that's going to be the big thing, and it is a big thing. But how is that going to affect everything as we're moving forward with the at-company protocol and with the Zariat IoT?
Well, 5G, first of all, 5G does introduce some of the new protocols that Colin's mentioned, and we do look to secure that. But it's those roaming interfaces, like I said, because it has to work all the way around the globe. Nobody's going to accept not having coverage when they go abroad on holiday. It's going to take a long, long time to do that. So those legacy protocols we were talking about, they're going to be there for a very long time. But the thing with 5G is it actually starts to expand the threat because it's also a consolidation of technologies as well. So HTTPS, for instance, is used within the 5G core. That's a bit of a problem, really, because everybody understands that. It's an IT protocol everybody understands. Telco's been lucky to an extent that it's had security through obscurity. Nobody knew what it was, so nobody knew how to hack it. That's falling away now. But if you start if you consolidate technology and start putting HTTPS and other protocols that everybody's learned at college in the middle of it, you've got a big problem. If you add to that the fact that it has to be virtual as we move forward to 5G, that's already happening in 4G with the LTE, then you can start to see when you put that in there and you have all of those cloud environments, or probably more likely cloud virtualized and hybrid environments, giving you a heterogeneous network to look after, you've got a massive problem, especially, again, as Kevin said earlier, when you put billions of IoT devices on there as well, all doing different things that you don't know what they are. So 5G is great, but it's definitely not the silver bullet.
Kevin, Colin, anything to add?
Well, Jimmy's the expert on this stuff, but I will say that I'm looking forward to the day where I don't have to have my home Wi-Fi. I can just use 5G. It's sort of crazy that we all have to run home networks these days. That to me is pretty crazy. So I think what we find is 5G will become the networking of choice, and you just won't think about having to set up a home Wi-Fi network. So when that does happen, then you better make sure that your devices are hardened enough to live on the raw internet. So that there's pros for sure, but there's also a whole bunch of security to be thought about to bring those devices up to a reasonable standard. We don't tend to think about this at the moment because we all think we're safe behind our firewall, our home router. We need to think a little bit more seriously about that.
Okay, so I think that's really sort of wraps things up for our panel here today. And I'd like to thank Jimmy, Colin, and on behalf of Zariat, the at company, I'd like to thank the listeners for listening into the IO Internet panel. And I guess that's it. So we're back to Tyler, excuse me.
Oh, that's okay. Thank you all so much for having this panel. That was awesome. And since we're talking about IoT, why don't we see it in action? We can start off with Colin, who will be demonstrating the ham radio using the app protocol. Thank you, Don. It was great having you moderate this panel. And
my pleasure. Thank you.
Kevin, it was great having you. Thank you. And Jimmy, you will be back in a second.
Yep.
All right, Colin. It is
all right, Tyler. I'm up. Am I? All right. So one of my hobbies is ham radio, amateur radio, and essentially a radio. Let me see if I can share screen. Tyler, probably have to help me out here. Let me see.
Sure thing. Just you can share your screen. I will.
You can pick that one there. And
for the person in chat, no, we are only just getting started with the demos. We just finished a panel discussing IoT. So you got here at the perfect time. Unless you want to watch the panel, then I'd recommend watching the YouTube video before this.
Yeah.
Okay, Colin, take it away.
Yeah, no worries. So this is an amateur radio. This is an ICOM 7100. And the way this stuff works is you pick a frequency. This is the frequency here, 14 megahertz and 0.2394. Let's move that up. And what you do is search the bands, search the radio, and see if you can speak to somebody, which is just a great hobby. I can speak to people all over the world with this little radio. But obviously, if you want to speak to somebody in particular, you've got to find out what frequency whoever you want to speak to is actually using. And that turns out to be a particularly difficult problem. So I've been on email lists, I've been on chat rooms. There's all sorts of manner of things to do that. But it seemed like a pretty good way of using an IoT device, in this case, a radio. If I could connect that radio to the app protocol and advertise what frequency I'm actually listening on a web page, but do it securely, then that would seem like a good thing. So that's exactly what it did, and it's an open source project, as everything else is at the ad company. That's in my personal repo on GitHub. And if we look down here, there's my radio. And there's some implementation details how to do it. But this is exactly what's happening. We have this is my radio here, and we have a Raspberry Pi, and the Raspberry Pi runs two things: something called Root Control D, which is a daemon that speaks to the radio and actually talks over the USB interface. And then a bit of code that I've written called sync to wavy. .sh. So it's a shell script program that uses a ad company binary that you can build called @CLI, and this repo explains exactly how you can do all that stuff. So as I mentioned just with Jimmy earlier on, this little @CLI actually makes a call out through the firewall, so I haven't got any firewall ports, and it talks to the app platform and updates my AI6BH. So AI6BH is my call sign. And it updates that, so anybody in the world can go to my wavy page and see what frequency I'm on. So let's see that in action. So I'll bring up my camera again. And there's my camera. If we go to my wavy page, and I bring the camera back up again. So this is my wavy page, this is the camera, and if we scroll down, so you can do this yourself at home at AI6BH, so wavy.ng and at AI6BH. You can see some information about me, and you can see that I'm listening on 14.232, and I'm on my IC7100. So let's test the demo gods. Let's change frequency. Let's move up to this frequency 2330, and let's see what that updates. And looks like it did. So the demo works. So this is an IoT device at home, my radio, talking to a Raspberry Pi, which is a credit card size computer. It's talking to the app protocol via a little program. I'll actually bring this down here. You can see it. And you can see when I, let me just show you. I'm famous at the ad company for doing text demos. So let's change this frequency again. Actually, I'm just going to change to a different band. Let's go to the 7 megahertz band. So with 7245. And you'll see I changed to lower sideband, and there's two commit IDs. So the commit IDs is obviously talking to the back end of the app protocol, and you can see there I'm looking at 7.25. So anybody in the world can go to my wavy page and actually see what frequency I'm on listening on a radio, and that's sort of it. But today I want to announce something new. What I found was not many people like interfaces like this. What they'd much prefer is a Flutter application. So I've been working on a Flutter application. to effectively do all that stuff. You still need the Raspberry Pi, but wouldn't it be nice to have a Flutter implementation? And I'm calling that UI, and it's Hamlib Web UI. And again, all this code is available in the GitHub repo. So I'm going to log in with my @ AI6BH, and I'm going to add a radio. So my radio name is IC 7100. That's the name of the radio. I know the IP address because it's on my home network. So 1.2, and it's on port 7100. So I've added a radio. You can see that it's not picking up anything because I need to activate it. So if I switch it on, I hit the active button. It's read that. You can see that actually, both of these two things are actually saying exactly the same thing. If I change the frequency, we'll go up to 781. That's there. You can see that's all updating pretty nicely. If I change to maybe I change to FM, you'll see I'm on FM now. I change to AM, I'll be on AM, and we'll go back to single sideband. And obviously I can add other radios. I actually do have another radio connected. It's an FT91A. It's on the same IP address. 1.2, and it's on port 1000 there, and we'll activate that one. And you can see I got two radios there that I can track on my mobile phone, and they will update the website, so there's no need for all that sort of tech stuff. It's nice to have a sort of a nice UI running on your phone. And that's the end of the demo. Tyler, save me.
I'm here.
So everything did work, which was I'm very pleased about that.
That's good. The demo gods were on your side. We do actually have a question. Someone asked, what machine is that? The one you're using to change frequencies?
Oh, the ham radio itself is an ICOM 7100. It's an all-band receiver, and it can transmit on the all the ham bands for the US, which means I can speak locally to people or people around the world. Actually, I have a regular hookup with somebody in South Africa, so I can speak to from my house in California to somebody in South Africa. If the sun gods are with us, actually we depend on the sun to energize the atmosphere, so I can bounce radio signals around the world. But yeah, that's what it is. And
Rocky says, I was hoping you'd use the old school LCD typeface.
Yeah, you like that, Rocky? Yeah, most of the ham radios are still using LCD. So yeah, the app look and feel is using LCD as well. That was a lot of fun, right in the Flutter app to do all that stuff.
All right. Thank you so much, Colin. That was incredible to see. I always love seeing your demos. They're always so unique. Sure.
I'm just old. That's what you're trying to say, so.
Okay. All right. So up next, thank you, Colin.
Thanks a lot. Thanks for having me, Simon.
No, thank you. And you did the panel. You did two things today. It's awesome.
Oh, yeah. I'm busy.
All right. Now you can have your coffee break.
All right. Coffee it is. Thank you so much, Simon.
Okay. Up next, we have Jimmy from Iot, who will be demoing their SIM cards. Oh, I brought his stream up, but not him. Okay, there we go.
That's okay. The sun's come around. You can't even see me at the moment. So, yeah, I'm just going to go through exactly how our how we deliver the app company's technology onto our SIM. So this diagram represents an IoT ecosystem. You can see the application server on the right. That's where all the data is collected, etc., and the IoT on the left. So the device registers to the cellular network in our case, and it uses a SIM to do that. And then we have the signaling plane, which goes over the top part. And that's essentially, as I was discussing earlier, is what allows your phone to work. So the 4 bars and the fact that your phone rings, that's the signaling plane. When you start to make a call and it's carrying voice, that's the data plane. So you see in the middle, we have a signaling firewall. And I mentioned before that we take a lot of security devices off of our sister company, and that's basically how we secure that area. So that's essentially what our core network looks like. So that signaling firewall protects all of the signaling path, and then we look at the data path. We already, before we met the company, we secured via VPN to the cloud where the application servers would be. But as I said at the beginning, that just wasn't cutting it really for me. So what we did is we added that root of trust that I was discussing before, the keys on the device, actually on the SIM that's in the device. And using those, it provides end-to-end security. And as I said, I'd love to say it was me who came up with that, but the smart people at the GSMA came up with the idea first. They'd already thought of it, and it was IoT Safe, as I outlined earlier. And as I said, that's an absolutely fantastic initiative, and it definitely will keep its place. But as I said, it's quite heavy, and it does cause some barriers to adoption. So we found the company, and we used our encryption technology. And to be honest, it was a lot more than I actually expected. So it's actually been better for us, and I can see some areas that it's actually, seems to me, a lot better than what the GSMA are doing. So there's a lot there, and as I said, when we start to take the company's advanced technology, put it on a SIM with some other of the tamper deterrents that I mentioned, then you have a root of trust, and that root of trust is really secure and can actually be used across all of your IoT. So it's something that, yeah, I think it's really exceptional. But let's get to the interesting bit. We'll do the demo. So my demo is not going to be quite as good as Colin's, because I have to have a video, so because it's on a different set of devices. So I'm going to show a demo now where we build and download a file to an eSIM, and what we'll do is we'll then initialize the profile and confirm it works, and at that point the SIM is ready to use on the mobile operator under whoever's coverage it just happens to be under at that point. To achieve that, we use a German software tool. It's a company called Comprion. They make loads of test tools in this area. That they're very, very good. And the name of the one we use is called the EU ICC Profile Manager. So just for your knowledge, EU ICC is just the next generation of SIM. It basically does exactly the same thing, but it's more flexible, and you can put multiple applications on it. So it's just the next generation, basically. Inside that Comprion tool, it has two elements, the creator and the loader, and they do exactly what you'd expect, really. You can build the profiles in one and you can load them in the other. And this whole process mirrors the standardization done by the GSMA. So they have a set of manuals, for want of a better word, labeled SPG and various numbers, and they outline how this works. So if you look at the box, the subscriber management data preparation, or the SMDP, in the grey box at the top, that's essentially the Comprion profile creator, and the subscriber manager secure routing, SMSR, in that sort of bluey color box at the bottom, that's the Comprion loader. So that's the main elements, except for the most important one. The most important one is a guy called Jerry, because I can't do this. He made all this stuff work, and when I run the video, he will be the one driving the mouse. And what you'll see is he's actually a lot faster than me. So I'll be pausing the video at various points just to try and keep up. Okay. So on this screen, we join Jerry, and you can see he's in the profile creator tool. This is where he's built the profile, and you can see the data here. You can see that we've fogged out a little bit here. That's just because it's a little bit sensitive at the moment. Let me start the video. That would help. So the creator does a decent job in verifying the configuration, but we found that to be absolutely sure, you need to use the loader. And you'll see Jerry change into the loader tab in a moment. There he goes. And now we're in the loader. Before he does that, he needs to go to the card collector, and let me just pause it. Go back. Sorry, I missed it too slow. So here we're in the card reader. What he's about to do is he's about to go and connect to the card itself. So at this point, the card has the manufacturer's security policy and certificates on there. So we obviously bought the eSIM, so we know what they are, and it's accessing it via the Bootstrap default profile. Okay. So, oh, very good. So now he's got the profile, and this is quite an interesting screen. What we can see here is a number of things. We can see the EID. So the EID is the embedded identifier document, which is basically the unique identifier for an eSIM. You can also see two different connection types, SCP81 and SCP80. So the secure channel protocol 80 and 81, which probably rings some bells for some people with TCP and HTTP. You can see that you'll see those in a later trace. The one we use is the SCP81, and the reason for that is it uses a secure HTTP session with, as you can see, TLS. And we like we feel that's a much better solution. It's quicker, but it also means we can directly address the card, and plus it's PKI based. The SCP80 is really like it's like communicating to the eSIM using encrypted SMS, and it can only use symmetric keys. So a lot of people use it because it's a little bit more simple, but we're not doing that because Jerry likes to do things properly. Okay. So the next thing he does is scan the card, and when he does that, he picks up the Bootstrap file, which, as I said, is basically the default profile in the SIM. You can see the last 4 digits when they come up are 1200. You can see that there. That's you'll notice that when we add the next one, it'll turn to 1000. Next thing he needs to do is find the profile he's built, and you can see it'll be labeled SCP81. And right, okay, this is a good one. Now he's uploading it, you can actually start to see some of the details that's within the profile. The nice one I quite like, he's called it @Zariat, which is quite a nice name, I think. But it also has the IMSI. So the IMSI is the International Mobile Subscriber Identity. So you have two identities when you look at a SIM. You have the actual SIM's ID, the EID, but you also have the IMEI even. You also have the IMSI, which is the basically what the network uses to communicate with every IMSI on it. I think that's basically it. Oh, you can see it's ASN1 as content as well. So let me restart this and I'll go on to that. So ASN1 format is extensively used in telecoms. Is it running? Yeah. Okay. It's extensively used in telecoms, and it's this language you can see here. Where it uses a lot of unique IDs, and a lot of the stuff in those curly brackets. I'm going to start this again because I think it takes some time. He goes backwards and forwards. A lot of the stuff you can see in those curly brackets are all they have to be exactly right, or you have a problem. They're mandatory as well, and that's another reason we leave this to Jerry. Right at the end, he finds the section where we've put the company's information. So it's going to go blue in a second, but unfortunately I had to blur it out. The important thing there is not only does it have to be written exactly correctly, it also has to be positioned in exactly the right way. So you have to position it in the overall file system in a place that won't cause problems in the future, because when you start to address these things, they need to be there. This is really the clever bit, because this is the non-standard files, and it lives actually in a bit of a counterintuitive file called the generic file system, but it actually lets you create bespoke files. It's a bit of a weird the way they've done it. But once we have that in, we're able to start to move forward. And what he'll do as we restart it is he'll start to move to actually download that profile into the into the UICC SIM or SIM itself. So earlier I mentioned that it was all standardized and there was an SMDP and SMDR. So there you go. There they sit. There's your profile builder and there's your secure router, but it's called loader in this case. And what we're going to do is we're going to start moving that through and we're going to start downloading the information. So this trace you're going to see when I restart is changing real time. So essentially it's just like a Wireshark trace, but it'll allow us to watch each message and each response. And obviously that makes debugging that much easier, and each action, as you can see, has got different different IDs. So whenever the system, when we look at the logs later, we can just identify those very quickly, and we can do the debugging that time a lot quicker. So let me start that off. It takes a little while. So you can see that the system is working its way through. I'm waiting for one particular message, if I'm honest. And you can also see that when we were looking earlier, you can see it talked about the ES interfaces. Where is it? Come on. There, that's the one I wanted. Okay. So right at the very beginning, this whole session was kicked off with a message from the MNO, which would be us in our case, to the SMDP, which is the profile creator, and then that pushes it to the router, and then it went to the SIM. And now what we can see is we've responded, and there's been it's essentially said, I've done what you asked me to do, and the MNO is now asking for an audit. So it's essentially checking that everything has been done correctly, and you'll see a list of messages now while we try and move forward. Once they're completed, what will happen is the MNO will be informed. Oh, there we go. Perfect. The MNO will be informed, and essentially it's just said, yep, everything's okay, and they can move forward from there. What that means is the MNO is able to it knows that the app profile is now activated. And I should have mentioned actually, you'll see here just off screen that there's two profiles on this SIM. The profiles always live there, but they can only one can ever be live at any one time. So now that the app profile is active, by direct implication, the original bootstrap file is now inactive. But the new ID is installed, but it's not activated on the MNO's network. That would have to be, to do that, it would have to check the IMSI and make sure that everything was okay there. So that would be done on the core mobile network. Have I started it? Yes, I have. So you can see there the two files I was speaking about. He's enabling the profile now. And what he should do, yeah, okay, so now we've flipped over. So what he's going to do now is just go back to the home page, and we're going to go through the home screen logs. And as he works through the logs, what we'll see at the very end somewhere is, there we go, the UICC is running and the application is initialized. So hopefully you can see my mouse, but it's about 1, 2, 3, 4, 5, 6. That's 6 from the bottom. So that's how we do it, basically. It looks, it's once you have the profile built and once you understand how the file systems work, then it's still a bit bits and bytesy, but that's just what ASN.1 is like, unfortunately. The UICC runs a level of Java, and we can access it in various ways. Every time we access it, you saw when we were downloading, that was secured via TLS. When we access the information, we access the key from the device to the SIM, that's also encrypted as well. So you've got double encryption there as well. That's basically, start it again. That's basically it for my demo. Thanks for that. Not anywhere near as good font as Colin, I'm afraid.
Oh, don't stress about it, Jimmy. I think that was great. That was very entertaining, and I've never seen anything like that before. So I think we all learned a thing or two just now.
Okay, that's great. Yeah, the joys of telecoms.
Awesome. Well, thank you so much, Jimmy, for your time today, especially in the panel and your demo just now.
No problem
Do
at
you
all.
have any final remarks before you're off?
No, it's an absolute pleasure working with the Act Company. And if anybody has any ideas for IoT, please get in touch. We'd be happy to try and help you achieve whatever you're trying to design or build.
Totally. All right.
Cool.
Well, thank you so much, Jimmy. Have a great night. I believe it's nighttime for you now, isn't it?
Yeah, the sun's disappeared. You can't see me now. But yeah.
Well, have a great one. Thank you
Thanks,
so much
Tyler.
for joining, and see you later. Okay, now we will have sorry, let me just get their name up so I don't mess it up. The Rumi team, Team Rumi, and I will bring Alex up to the stage. And sorry, Alex, who are your teammates?
Hello, my teammate is Will.
Will, I knew that. I was just testing you. Okay, you guys can take it away. Oh, actually, before I just kick it off to you completely, do you want to say why you're here and where you're from?
Yeah. So our slides are actually a little bit of an introduction. So
Perfect.
We'll start with
Now
the
you-
slides. So we met the At company at CalHacks this last weekend, and we shared our idea with them about Rumi. We looked into their protocol, and we decided that we could use their services in our app in the future. So our app is named Rumi, and it was made by me, Alex, and my partner Will. A little bit about myself: I'm a first-generation college student. I'm a second-year EECS major here at UC Berkeley, and I encountered CS my first year here on campus. So I came to campus as engineer undeclared. I had no idea what I wanted to do. Didn't have any experience in pretty much anything besides just working in food for the majority of my youth. And I came here to take my first CS class. I loved it, and I've been taking CS classes ever since then. Some extracurriculars that I have going on right now are I'm an academic intern for the Intro CS class. I really felt that the academic interns made my experience and helped me to grow my passion for CS, which is why I'm decided to give back and do the same for other incoming CS students. I have interned at Microvu, which is a precision company, precision equipment making company, and I interned as a manufacturing intern there. And last summer, I interned at Keysight as a product support intern. Some hobbies are I like spending time with my family, so being away from home for college has been a little difficult. I try to go home whenever I have a chance. I like working out, and I love learning new things, which is one of the things that brought me to CS is the fact that it's so new and so open. You can always learn something new in CS. This is my LinkedIn here on this slide, and now I'll pass it on to my teammate.
Okay, cool. Thanks, Alex. So I want to preface this by saying that I actually met Alex at the lab that we do the academic internship work for 61A. So we just help out students, and we decided to do the hackathon together. And brainstorm came up with Rumi, and that's how we're here. Yeah. So about me, my name is Will. I'm a undergrad computer science student, so a junior at Berkeley. And in the past, I was a software engineering intern at Bird Eye in Palo Alto. So just did some marketing things and made a Chrome extension. And then also I was a commercial operations intern at GSR Energy in San Francisco. And so that was a lot of data stuff. And currently I'm doing a lot of data science stuff with UC Berkeley Center for the Built Environment with previous PhD student Paul Raftery. And yeah, just passionate about CS in general. And yeah.
All right. So now let's move on to our somewhat of a demo. We're going to show off what we were able to come up with this weekend at CalHacks. So this is cool. The website that we made. And
oh wait, Alex, I don't think it's screen sharing.
Oh, it's not screen sharing? Okay. Let me stop sharing this screen and try to share the other tab. Let's see.
So I can give like a quick preview explanation. So what we came up with was kind of out of necessity, not out of any other reason, and it is a roommate matching app for UC Berkeley students. And so first thing that we did was we developed this website to kind of showcase it. And yeah, Alex.
Yeah, so this is the website. We were able to get this website done. It's not fully finished, but it was definitely a good experience to learn a little bit of web development during CalHacks. And so if I click this link, this should take me to the dev post, which I think I have to reshare. It's not showing on here. Let me share again. Share screen.
Yeah, try just sharing your whole screen.
Okay. Let me see.
Yeah, I know it can be a little tricky when you just share like one screen at a time.
Yeah. Are you able to see this one?
Yep.
Got it.
Okay. So basically the inspiration behind our app Roomie was that we wanted to make the roommate finding process here at Berkeley a little bit safer and a little easier. The way Will and I found our roommates was totally not safe. We just sent out a post with all of our personal information on Facebook and told people a rough estimate of where we wanted to live. And so we figured that was not a good idea. We want to make it more secure, because sharing it to a platform like Facebook, anybody can see it. You don't know who's messaging you about wanting to be a roommate. It could be somebody that's not even at the school, just somebody living in Berkeley. And so our idea was that we wanted to make an app where it was secure, and we wanted to use the app company's end-to-end encryption for the messaging inside of the app, and for ensuring that anyone that logs into this app and makes an account is a UC Berkeley student. So it gives you that little, it just makes you more secure. It makes you feel more secure about who you're talking to, who you're interacting with, and ensures that the person you're talking to is a good candidate for a roommate. So Will, do you want to talk a little bit about a little more about Roomie and the idea behind it?
Yeah, so I can like kind of walk you guys through what would happen as a user of the app. And so it would just be for Berkeley students now until we move on to other schools. But for now, you'd sign in with your berkeley.edu email, and we would have some sort of verification process using the app company's encryption for that. And so that would make sure that the only people using the app are Berkeley students. And then you would basically fill out a profile with a little bit more about yourself and your housing interests. So it'd be like, okay, I want to live in Southside Berkeley, and between this price range, and then also a little bit about yourself, and what you're looking for in roommates. And then we would have some sort of algorithm that weights all of those. And sort of like Tinder, it has like a stack of other students who are more or less similar to you. And so the idea is that there would always be students to swipe through, but the ones at the top of the stack would be the ones that are most similar to you. And then when you find a student that you're interested in being a roommate with, then you'd swipe on them, and then you'd match with them. And then at that point, that would be, the encryption part where, you're talking in the app and the data is not shared. And then after that, the end goal would have to be to have those students live in a property off campus. Yeah. And that's basically the idea. So at the hackathon, we kind of like fleshed out the full thing. And so the app is not fully fleshed out. Like the actual app is not, we're not able to use it yet. But I think the most important thing is that this sort of like area, this market is not really tapped into, and maybe it's tapped into not at universities, but I think our big idea here is that there's no way for people to safely find roommates at UC Berkeley and other universities in general. So that's what I mean when it's kind of a necessity. Yeah.
Yeah. So right now we're still in the final stages of just fleshing out the idea, making sure that making sure that we know exactly the direction that we want to take it in before we start learning how to make the app and how to work with the app company to use their services for our idea. And we're happy to take any questions at this point.
Yeah.
Well, that was great. This is such a great idea, and you don't typically see, really good ideas like this come out from a hackathon. So I'm like totally impressed.
Thank you.
I guess I have a question. You do say you want to make sure that you have the proper idea and the fundamentals behind it. Do you have any idea as to when you want to release this to the public?
Yeah, so definitely we want to get it done before the summer, before the new cohort comes into the school, because that way all the new students, the new freshmen that are coming in and transfers, they're going to, hopefully by then the app will be circulating around a little bit, and we'll be able to send it out to all the new students coming in, because everyone that's coming in is going to be looking for roommates in the summer. So if we get it out before the summertime, I feel like that'll be the perfect time to strike with our app. So that's that's pretty much the timeline right now.
Awesome. That sounds good to me. I mean, best of luck. If you guys ever need help, that's what the app company's here for. We're here to totally support you and answer any possible questions for you guys. And
Thank
again,
you.
congratulations on winning. I can see why you won now.
Yeah, thank you.
All right. Have a wonderful day. Thank you so much for joining this demo day.
Cool.
And
Thank you so much.
have a good one. See you guys later. And okay, so up next, we have Rent Easy with Trevor and Pratier. All right.
Hello, everyone.
Take it away.
Hello. So let's introduce ourselves really quick first. So hi, guys. My name is Trevor. I'm a first-year mathematics and computer science student at UC San Diego. I got into hackathons mainly during quarantine throughout high school at the time when I didn't have much to do. And I really just fell in love with the creative aspects of CS, and also the ability for you to be able to self-start something. It's kind of to bring this vision to life. And that's why I just love hackathons. I've been competing in them ever since. And I was super lucky to find an awesome team here with Pratier, Samir, who had to leave a little bit early, and also Subham. And all four of us, we came up with this awesome idea called Rent Easy. And Pratier, do you want to go ahead and introduce yourself? I think you're muted.
I hope now it's fine.
All right.
Okay. So yeah, as you mentioned, so I'm also an electronics and communication engineering undergrad. I'm actually from India, and yeah, I'm in my senior year, and I'm happy to be here. So yeah, this is our project, Rent Easy. Probably Trevor will you be taking this up, if you will?
Sounds good.
Okay.
All right. So to put it most simply, Rent Easy, which is our hackathon idea that we submitted to CalHacks this year, is a smart portal that allows people who are looking for homes, mainly targeted towards students who are looking for affordable housing, to connect better with homeowners. And we developed a platform that addresses a lot of the flaws that you normally see in other apps that are already out there, like Redfin, Zillow, etc. So let's take a look at some of the problems that we first identified. All right, so the first problem that when we thought about when we looked at students trying to find affordable housing, and just renters trying to get connected with landlords in general, was a lack of communication. So traditionally, a lot of the communication between the landlord and the renter happens through some sort of real estate agent, often hired by the landlord. And the problem with having a middleman, like a real estate agent in the middle, is that it's kind of a 20th century idea that we need this middleman in order to facilitate conversation and to facilitate everything from private documents to just inquiries about like fixing the toilet or something like that. And having to pass it through a middleman can first cause miscommunication, but more importantly, it can also pose as a privacy issue. So that was the first problem that we pointed out. The second problem is during the actual seeking process, where a tenant is looking for a place to stay at, they usually have to go through an agent or some sort. And these agents are usually motivated by commission over actually helping their tenants. A good example of this is because real estate agents, they actually make a commission. Usually the industry average is around 6%. They are actually incentivized to get the tenant to find a location that is more expensive or has a higher cost so that they can have a higher, their portion of that commission makes them more money. And they employ a lot of different strategies to do this. One strategy, for example, would be to show a very mediocre home in a lower price range on purpose, and then immediately take the tenant to upper range homes that are more expensive, to show and convey this contrast, to try to get the tenant to maybe shop out of their price range. So because of this, there's an inherent bias when you're trying to look for a property through real estate agents, which is another problem that we pointed out. And lastly, the third problem is that landlords themselves, they're trying to get their place rented out as well. And traditionally, there's a lot of different methods. I mean, they can go through some online platforms like Zillow, another very popular one, if they're especially trying to appeal to students looking for affordable housing, is through Facebook Marketplace and making a posting on that. The problem with Facebook Marketplace and a lot of these other platforms is that they need to manually review applications coming in one by one. So there's no way they can easily filter through. Let's say they want someone who doesn't smoke or doesn't have any pets. They need to manually read every single application, which is time consuming. And on top of that, when you post on places like Craigslist or Facebook Marketplace, which is open to the public and very accessible, you sometimes get thousands of unverified individuals that just pop out of nowhere. And you can even be prone to botting. So these are some major problems on the landlord side. So now that we've established some problems between both through communication, through the landlords, and also through the agents, let's look at some of our solutions that we thought of that we incorporated into Rent Easy. So our first solution is that kind of solves the problem with cutting out the middleman of the real estate agent when you're trying to find a tenant's trying to find a place to stay at, and a landlord is trying to find a good tenant, is a smart rating system. So basically, this smart rating system that we implemented in Rent Easy facilitates the matching of the tenant and the house owner based on their previous reviews. So something that's really interesting about Rent Easy specifically is not only does the tenant get a chance to review the landowner's property and their service after their term has ended, it also works the other way around. So landowners can also get a chance to rate their tenants. And over time, tenants can build up a good rating on their profile, which makes them more appealing when they're trying to apply to other places to stay. And this is really good because it kind of solves this real socioeconomic problem we have here, where, sometimes if you were a landlord, you would maybe rather have someone who paid like a little bit less but kept the place clean. And using a review system like this allows people who might not be as doing socially economically well, but are still incredibly responsible and caring of the living space that they're in, to have an upper leg in the housing market. The second solution that we came up with is when you're coming up with a contract between the landowner and the tenant, the legal language can be really complex, especially looking through the contract and all the terms. Sometimes you even need to hire a lawyer in order to figure out everything. So something that we're planning to implement through Rent Easy is to have the two stakeholders build an understandable contract. And we haven't yet implemented this specific solution in our app, but we're planning to use natural language processing and other technologies that would make that would automatically interpret legal language and make it easier to establish trust and have a mutual understanding and agreement on these legal contracts that are normally very restrictive and not accessible to normal people. And then the last really cool thing that we implemented was an interplanetary file system. We used IPFS to store contracts that are made between the renter and the landlord, and this ensures that the contract will not be duplicated and cannot be tampered. So that's a lot of talking, but let's take a look at the demo. So since Samir isn't here, we're unable to do the live demo.
I think Samir-
Actually, I just.
Oh, Samir's here.
Yeah,
All right,
Samir's
Samir,
here.
do you want to go ahead and do the live demo? I can stop
Yeah,
sharing my
sure.
screen. All right.
So, let me share my screen. All right, can you guys see my screen now?
Yep.
Yep.
So,
Yeah, so this is what you guys kind of get when you enter the app for the first time. You kind of have this simple login screen, and you also have an option to sign up or register. When you're trying to register, you can either register as a landlord, so a person who's renting out a place, or a tenant who is trying to find a place. Now let's try to sign in this time. So let's add one of the demo accounts that we created. And when you click sign in, it will essentially try to set up the @ for you and for your account. So luckily, I've already set up an @ for this account. So I'm just going to use the one that I have. And click submit. And then upload our backup key file. And this should get us authenticated to the main part of the app. And the app consists of 3 tab bars. Essentially, first one to be exploring the houses you have. So if I scroll down just over here, you'll see all the houses that are available to me and near my place. And I can even choose to, let's say, click on one of these houses where I get to know information about the square foot, bedroom, bathroom, garage, and you get to have this animation on top just to show us pictures of the house. And another cool thing and cool feature that we have developed is map view. So you can essentially click this and have a 3D map of all the rental units available around you. So if I zoom out, we can see 1,000 over here, 850 over here. So with this map view, you can just click on one of these, and then it's gonna pop up a page like this, and then you either can go to details where you can apply from there, or you can even come back and click apply from here. And when you click this apply, it will essentially use all the past places that you've stayed with, and it's gonna use it something like a resume and apply to this house, where landlord can filter through or see what you've been through. It puts all your references together. Now, let's say that you've applied to this house and your landlord really likes your profile. So now he or she decides to chat with you. So in the chat screen, we can see that we already have a chat set up with one of the landlords, where it's a demo chat. And you can see the landlord texted, "I really like your profile," and we decide to schedule a meeting. We can just reply with "sure," and then go on with it. Another feature that we developed was essentially your profile screen. So in your profile screen, let's assume that you've been with this landlord for about your tenancy's 6 months or 8 months, and you've been there for about 6 months now. So you have about 2 months left for the end of your tenancy. In your profile page, you can not only see the previous apartments that you've been to, you can also see the details of your current apartment, and you can also choose to rate your landlord. And when you click to rate your landlord, you can give it, let's say, 5 stars. You're doing great with your landlord. You can say amazing, and then submit it. And this feedback overall just makes our community better. And same thing applies to the landlords. Landlords can also get to rate you, and they give their opinions on you. And this is the tenant version of the app where we developed in this hackathon, and we're planning to develop the landlord and many other versions. So that's it for the demo.
Wow,
All right,
wow. That is insane. Sorry, did you have something to say?
Yeah, I was gonna go ahead and jump back into a couple more slides talking about our future plans and also what we have in our team. So I'll go ahead and share that to finish this demo off really quick. All right. Cool. Samir, do you want to talk about future plans? I think you're muted right now.
Yeah.
Do you want me to share my screen again, or are you fine with just sharing?
You can just use the screen that I'm sharing right now.
Okay, cool. So the future plans that we have for Rent Easy, this is planned to be in the first 4 to 6 months of the development. So we're essentially planning to design and build a simplified contract generated part where it takes away landlords who change the contract midway and then make new rules, and then tenants who just don't obey the rules. So instead, we can have a common rent agreement, and we would store it in IPFS, and we would probably polish this feature a lot more and push it to production. And then the first stage of production will actually take place near university campuses, because that's where a lot of students who come to university, they're either from their parents' houses, and now it's their first time renting a place, and they're really inexperienced. So Rent Easy aims to make this process a lot more smoother for them. So we'll definitely be aiming at university campuses where students in general have lesser housing experience and know less about how to rent a place properly. And our long-term goal is to make this app a standard of the housing standard for applying houses. So think of it this way: imagine this being a resume of applying to houses. When a landlord posts an ad, we also get to see his profile and see how good of a landlord he is. And the same thing with tenants. Tenants can just apply with their own profiles. So it definitely removes the intermediaries and makes the process a lot more smoother for both of them. And to incentivize students to use our platform more, we are also planning to partner up with companies near campuses where we would get free cleaning services available for them. So it's expected that it's normal that a lot of students are going through midterms, exams. So they really, there are sometimes around the month or term that they're really busy and they don't get to clean their houses enough. So we can actually offer them free cleaning for, let's say, one time a term to incentivize them to join our platform faster. And for landlords, we can either help them through helping many landlords that I own usually own more than one property. So we can actually offer them free help on managing and finding tenants and making the whole process a lot less chaotic.
Cool. And then we're just going to conclude with everyone on our team. So, yep, that's pretty much it for us.
All right, that is, wow, I'm so blown away, you guys. That is incredible work. I mean, wow, seeing just like the onboarding for, the app platform is cool enough, but you have like the chat feature, you have profile set up. You guys must have been like working constantly, like at least 48 hours worth of work. That's an awesome job. Due to time constraints, I wish I could ask you more questions, but I cannot. But amazing work, you guys. This is incredible.
Thank you so much.
Thank you.
Thank you so much.
All right. Have a wonderful weekend, you guys. I'm sure this is the first time you're going to get sleep in a while. All right. And see you later.
Thank you.
Thank you.
Okay, I promise this is the last demo, and I will actually be sharing my screen where it is a recorded video. So let me share my screen, and here it is. So this is Team Cypher AI. Unfortunately, they were unable to join us today, but we can see their recording.
Hi, we're Cypher AI.
Oh, actually, can you guys hear them? I want to make sure that you can hear them because that'd be really embarrassing if you couldn't. Oh, wait, uh-oh. Oh, wait. Oh, no. Did I? Okay, whew, I thought I lost it. I thought I absolutely broke demo day. Okay, hold on. Let me make sure I'm sharing my sound as well. Okay, I think it was fine. Yeah, audio good. Thank you. Thank you. Okay, sorry. Okay.
And it provides predictive learning as a service to IoT devices and more. My name is Raina. I'm a junior studying ECUC Berkeley.
I'm Kevin. I'm also a junior studying EECS at UC Berkeley.
And I'm Smith. I'm a senior studying EECS also at UC Berkeley.
So today we're just going to run over the problem that Cypher AI tries to solve, our solution, some technical background behind how Cypher AI actually works, some challenges that we faced, and some use cases that Cypher AI can be applied to. So what's the problem here? Well, 81% of Americans today feel a lack of control over their own data. However, companies need user data to offer extensive proprietary analysis. And these objectives can seem to be clashing. How can we get access to state-of-the-art models without ever having to fork over our data to companies? Therefore, we need to find a better way to offer services without compromising user data. Our solution, Cypher AI, allows servers to perform operations on encrypted data without ever having access to unencrypted user data. As a result, users can access the services that companies offer without having to give up their data. This allows people to take back control over their own personal data, which helps to foster trust between customers and companies worldwide today. So we're unique not only because of the secure privacy channels that we provide, but also because our scheme is applicable to any type of machine learning model, as well as most data analysis models as well. Two of our main features are fully homomorphic encryption, or FHE for short, and public key encryption. Fully homomorphic encryption is a method that allows servers to perform operations on data without needing to decrypt it first. This powers our main differential privacy feature, allows the servers to perform operations without ever having access to the user data in plain text, so users don't have to worry about companies storing or using their data badly. We also use public key encryption offered by the app company, which encrypts the communication channel and provides verification. And this prevents malicious third parties from ever gaining access to user data.
Let's talk a little bit about how homomorphic encryption and really homomorphic functions work. So homomorphic encryption works by allowing us to perform computations like addition or multiplication on encrypted data. An example of a homomorphism is described here with the exponential function and addition. So let's consider that example of an encrypted function or encryption function that takes in a number x and computes e to the x. Well, we know that from the laws of exponents, if we have e to the x times e to the y, that's equal to e to the x plus y. However, we also realize that if you take the encrypted version of x plus y, that's equal to e to the x plus y. That's pretty cool. So e to the x plus y equals e to the x times e to the y. But that actually means that the encrypted version of x plus y is just the encrypted version of x times the encrypted version of y. So we've actually discovered a way to, without ever decrypting the number, to actually perform a computation, in this case, namely addition. Now, fully homomorphic encryption removes the need for trusted third parties entirely. Users will send only the encrypted version of their data over a secure end-to-end encrypted communication channel provided by the app company. The server is going to receive the encrypted version, perform any necessary computations on it without ever being able to decrypt it, and then it'll send it back to the user who can decrypt the result of the computation. By doing so, we actually eliminate the trade-off between data usability and data privacy that we outlined at the beginning of our slide deck. Now, some challenges. Existing fully homomorphic encryption schemes can only provide linear operators like addition, multiplication, subtraction, matrix multiplication, and the like. However, we need nonlinear functions and operators, and because they're crucial to implementing any sort of convolutional neural networks, activation functions like ReLU or hyperbolic tangent. These are all very nonlinear. So one scheme that we saw that we could use from a research paper was to use polynomial approximations to replicate the effect of these nonlinear operators. But it comes at the cost of greatly increasing inference error. When tested in CIFAR10, a good reference data set, the model accuracy dropped 77.5% to like 95% in state-of-the-art architectures. So we actually kind of use a different scheme outlined in a different research paper called CareNets, which compresses high-resolution images and leverages Taylor series expansion of the smooth ReLU function, like a smoothed version of the ReLU activation function, and performs some very novel min-max normalization to bound the error. By doing so, we're actually able to achieve approximately within 3% of state-of-the-art error on some reference data sets.
So two of the common impactful use cases for Cypher AI includes such as IoT monitoring. So for products such as Amazon Ring, where you can use surveillance camera to detect suspicious activities or detect any motions at your home 24/7 hours. Now, that's really good. But the problem with that is that if you are able to submit these videos to Amazon Ring, that even if it is encrypted in the server, it's still possible that these service providers can be using our data in a way that we don't want it to have it. Now, that can also happen in healthcare systems, whereas there's actually the case where DeepMind have received data, patients' data from NHS, National Healthcare Service in the UK, about tumor detection, for tumor detection research. Now, the problem with that is that the users or the patients actually do not want their data to be shared with Google because they don't know what the purpose of that is. But we all know that, in fact, having these data is super crucial for DeepMind in order for DeepMind to be able to come up with some inference algorithm. So there's a demand clashing here, both in the patient's privacy and versus the research purpose. So in both of these cases, Cypher AI will be able to accomplish because using FHE, the service provider will not even be able to look at the plain text data. Now let's look into the demo of our application. So in this demo, we'll be showing how user can upload personal video and get face detection result from Cypher AI using fully homomorphic encryption. At the login screen, we see that the user will be putting in their username, password, as well as the @ key that the user has created on our app before. By clicking on login, the user will see two different demo options. For the purpose of this video, let's click on the face detection one. So the user will be then requested to upload the personal video. And by clicking submit, we can see that the user's video is indeed being encrypted. And together with the signature, it will be sent to the server for face detection inference.
Oh, whoa. That was crazy. Oh my goodness. I don't know about you guys, but I know what Taylor series is, but everything else went one time. That was awesome. Hakeem, thank you for linking that video in the chat. I know they did talk very fast and there was a lot of information to cover, but that was incredible. It is so amazing to see that people are just like that intelligent to come up with things like that. I mean, I could personally never. But yeah, Trevor, I totally agree with that. Being able to play around with, our own models and things like that would be amazing. I cannot wait for this to be released. All of these demos today have been incredible. I'm always blown away by the end of demo day. But I know I'm 17 minutes over, so I'm going to stop talking and I'm going to let everyone enjoy their Friday and their weekend. I hope you guys enjoyed it. I totally missed demo day, and I'm so happy that it's back in business. And I hope you guys really enjoyed this demo day. And I will see you all next time. Don't know when that is, but I'll let you know. Have a wonderful Friday and weekend. Yes, they were our winning teams. They were our winning teams of the previous hackathon. I believe it was Cal Hacks. And yeah, I will end that here. Have a great one, everyone.